Hello everyone, I'm Stigdha Kakkad and this is my channel AccelerateAICareers. Today we are going to solve a very interesting problem, LeetCode 48, rotateimage. It is a medium level problem, has been asked in Amazon, Microsoft and Google interviews in last 6 to 12 months. Now, this problem is very interesting. It has a lot of significance and different ideas. You will get a way of solving problems if you learn this question. First of all, we'll try understanding the question. And then I'll walk you through the algorithm we are going to use and finally the coding part. So let's get started. So you have been given an n cross n 2D matrix. So that is a square matrix representing an image. And you have to rotate the image by 90 degrees clockwise. Remember, clockwise, okay? And you have to rotate the image in place. That is, you cannot use an additional memory or an additional 2D matrix. You have to make the change in place. So that is the complexity here, okay? We'll just go through one example here. We have been given this array 1, 2, 3, 4, 5, 6, 7, 8, 9. And how does the rotation happen? So the one which is in top left here goes instead of 3. So basically 1 takes the position of 3 here. That is from top left it goes to top right. 3 goes to bottom right. So it goes in place of 9. 9 goes to bottom left. And 7 goes to top left. So the corners get moved this way. Now the inner square, if you see 4, 2, 6, 8, they also form a square just rotated by some angle. So if we see 2 takes the place of 6, 6 takes the place of 8, 8 takes the place of 4 and 5 remains as is. That is how the rotation is happening. So your input matrix is this essentially, your output matrix is this, even though the output matrix is shown, but you don't need to return anything since you are making the change in place. As mentioned here in the comment, do not return anything, modify the matrix in place. This is another example. This is a 4 by 4 square grid and you can see the top left 5 goes to top right here. The top right value goes to bottom right here. The bottom right value goes to bottom left here. And the rotation happens so on, okay? So let me walk you through the algorithm we are going to use to solve this question. We're going to do it in O(n) square time and O1 space complexity. Why I'm saying O(n) square time? Because the size of the grid is n square. So essentially you're going to go through the entire grid once. So O(n) square time complexity and O1 space complexity. If you have a better approach to solve this question after you have seen my video, let me know it in the comments. I would love to learn from you. Now let's see with this example how the rotation is actually happening. So if you see here in this grid, the one which is at top left goes here to top right in place of 3. Now you will save this 3 somewhere in the meantime, right? Some temporary location. Then this 3 takes place of 9, that is bottom right. And you will save this 9 in a temporary variable somewhere, right? And then this 9 goes to this place 7, that is bottom left, and you will save this 7 somewhere, and finally you move this 7 to 1, okay? Same way, this other grid, a part of the outer layer, but internal from 1 to 3. So 2, 6, 8, 4, this again forms a square, a tilted square. So you'd see like this 2, again top is here, your left moves inwards. So your left is at index 1, okay, where the 2 is placed. And your right will move here, index 2, 1 here, where 6 is placed, okay. So you're essentially tilting the square. So now, again, your 2, which is in top left, goes to 6, which is top right. Your 6 goes to bottom right, where 8 is there. Your 8 goes to 4, where bottom left. And 4 goes to 2, that is top left. So that's how your rotation is happening. And finally, when you come to internal 5, then it remains as is because for it there is no rotation happening, like there is nothing to replace, okay? I hope you understand this rotation. Now I'll explain the same thing using a 4 by 4 grid and then we'll deduce what is the algorithm we are using here. Now let's look at this 4 by 4 grid. I have marked the top, left, right and bottom here. And this is my 0 by 0th cell. This is my 3 by 3 cell. Because the matrix is 0 to 3, 0 by 0 to 3. So 3, 4 by 4. Okay. First of all, we'll talk about how to move the corners. So this top left goes to top right, as you can see from the black arrow here. The top right will go in place of bottom right that is in place of 16. This bottom right will go to bottom left, that is in place of 15, and the 15 goes to here, top left. That's how the corners are rotated. One thing to note here is when you're moving 5 to 11, when you replace it, then you have to store 11 in a temp variable. Then you move that 11 from that temp variable to 16, and you have to store that 16 in a temp variable. Then you have to move 16 to 15, and you have to store 15 in a temp variable. And finally, you move 15 to 5. Now we move one step ahead. So essentially, you move one cell inwards. So this 1 goes to this 10. This 10 goes to this 12. This 12 goes to this 13, and so on. Then you move one more cell inwards. So 9 will go to 7, 7 will go to 14, 14 will go to... Once you are done with the entire outer layer, then you have inner square, which is 4, 8, 6, 3. So you draw one cell inwards from everywhere. So essentially, the top reduces by 1, the bottom increases by 1, and then you make the same rotations. So 4 goes in place of 8, 8 goes in place of 6, 6 goes in place of 3, 3 goes in place of 4. One thing to note here is, even though you are doing the replacements, if you look at the rotation of 9 to 7, 7 to 14, 14 to 2, you are doing just 3 rotations because you have already made the other rotations in the outer layer. So I hope that is clear. It doesn't affect the time complexity, but it is good to know that you're not making n rotations, you're making n-1 rotations. Okay. So essentially, whenever you are rotating, you are making n-1 rotations and not n rotations. Keep that in mind. Now, how to handle the use of temp variables? How can you make sure that you're not using so many temp variables? So for that, even though we have to do rotation 90-degree clockwise, when we are rotating, instead of doing clockwise rotation, what we are going to do for the corners or for any rotation for that matter, when we are rotating, instead of going clockwise, let's do anti-clockwise. So we will first store our top left value, that is this 5, in a temp variable. So this place gets vacant, okay? Now, I'm not going to put that 5 from that temp variable to 11. No. What I'm going to do, I'm going to move anti-clockwise. So since this place is free, since you stored 5 in a temp variable, I will replace this from this 15. So I will bring this 15 first here. Then this place I can replace, right? Because I have moved 15 here. Then I'll move the 16 to this place of 15. Now this place is free, right? Because I have already saved 16 here. So then you can move 11 here. And finally, this place is free, right? Because you already stored 11 here. Then from your temp variable where you stored your top left, because this top left you already replaced by 15. So you have to use that temp variable where you stored top left and you move that here. So keep this in mind. This will help in coding. So finally, I have explained you the entire algorithm, how we are going to go by the grid. Now I'm going to walk you through the code and I'll ask you to code with me because this is a little complex code. It will be better if you code it with me and maybe watch this video once again to understand what all the changes are there when we are coding. It will help you immensely to understand other rotation of image questions as well. Okay, so let's start coding. So I'll begin by initializing my pointers. So my left pointer would be initialized by 0, right pointer would be length of a matrix -1. After that, I will loop until left crosses right, because when that happens, that means you have looped through the entire matrix and you can stop. Then I will do the rotations. How many rotations do I need to do? So like I told, if there is n by n matrix, then you are essentially making n-1 rotations. So essentially for I in range left to r-1, or you can say r-l is the total number of rotations. Now initialize my top and bottom pointers, which I can take equal to left and right. Okay, so now I will save the top left in a temp variable. That's how we did, right? We first saved the top left. So I'm naming that top left temp variable as top left and I'm saving matrix top left here. Now I will move the bottom left into top left. Okay, so matrix top L will be equal to matrix bottom L. Now I will move bottom right into bottom left. So matrix bottom L is equal to matrix bottom right. Then I'll move top right into bottom right, and it will be matrix bottom R equal to matrix top right R. Now there is one thing which I have not taken care of, which is this index I. So I have not added that anywhere. So I need to add that. But first you need to understand how we are using this I. So when you have finished one cycle of rotation, like you moved 5 to 11, 11 to 16, 16 to 15, what do? You bring your left pointer from 5 to essentially 1. And you bring your bottom pointer from 15 to essentially 13, right? So you're basically using that I to change your top, bottom, left and right pointers. So that's what I'm going to do. So you increase your left pointer by I. Okay. Then you also, since this is also, you also increase your left pointer by I here. You reduce your bottom pointer by I. And the same thing you're going to do here. You reduce your bottom pointer by I. And then you reduce your right pointer by I. And you reduce your right pointer by I here as well. And then you increase your top by I. And there's one more thing we didn't cover. So we have to save the top left temp variable, right? So that we'll move the top left into top right, because that is one rotation which we didn't cover. So matrix top plus I R is equal to top left, because you saved that value in the top left temp variable. Finally, I can move outside the loop, and what I need to do, I reduce right pointer by 1 and I increase left pointer by 1, and that's it. You don't need to return anything because you are making all the changes in place, and this will be your entire code. So let me just summarize the code for you. I just initialized left and right pointers by 0 and length of matrix minus 1. Then I initialized a while loop until left crosses right? So L less than R. After that, I introduced a for loop which goes for n minus 1 rotations, that is for I in range R minus L. And then I initialized top and bottom variables which are equal to left and right variables. And then I made the rotations in anti-clockwise direction because I have to make use of less temp variables. So I first saved the top left value in a top left temp variable. Then the top left place is free, right? So I move my bottom left value to top left. And then I move my bottom right value to bottom left. And then I finally move my top right to bottom right. And last but not the least, I save that top left value from the temp variable to top right. And that's how your entire cycle of rotations gets completed. And I make use of I index to move inwards. So to move inwards, I have to increment left by index I have to decrement bottom by I have to decrement R by I, and I have to increment top by I. So that's the entire code. And finally, I change my right and left indices. So I reduce R by 1 and increase L by 1 for each loop until left crosses right. I hope the code is clear to you. Let's run. So it's accepted. Let's submit. So as you can see, our code is done. If you have any questions, mention them in the comments. If you like my way of solving the problem, subscribe to my channel. It gives me immense encouragement to see your shares, likes and subscriptions. But more than that, please do comment how you like my problem solving. I would love to know your responses. Thank you.